Brilliant, thank you. Okay, as you will have heard, again, through most of the week so far, many of our adopters not only want to, but need to deploy their switch on premises on their own server hardware. So we have a work stream focused on providing support for on-premises deployments. Mojaloop was mostly developed on cloud infrastructure. Although the abstraction layers chosen, Kubernetes, Docker, for example, were chosen deliberately because they're portable across many deployment scenarios. But most of the experience in the community had been gained through deploying Mojaloop into cloud environment. So this work stream was spun up, was created to focus some effort to understand what different challenges might be faced and what we could do as a community to help people who want to deploy Mojaloop on premise. Our focuses have been to enable starting small to minimize initial CapEx and with cheap unit cost to add scale after that as traffic grows. As for all of Mojaloop open source software, we make sure that there's no license fee required technology in the toolset. But at the same time, we need to facilitate carrier grade security, reliability, and resilience. The term carrier grade is often used to mean the very highest level of security, reliability, and resilience. But this space is mature. People have been deploying servers and applications on servers for a great number of years now. And there's a lot of skills out there already. There's a lot of people in the world who are very good at installing, configuring, commissioning, managing, maintaining physical servers in data centers. And we wanted to use tools, technologies, and components that would be familiar to those people. So there was no huge learning curve required. So you may remember from the mid-PI review, we said that we still had one last niggle with our infrastructure as code toolset. As you saw in the Comesa presentation, where they're using infrastructure as code to deploy and manage their 7 Mojaloop deployments, the control center itself, the management tools that deploy, configure, maintain, and monitor each Mojaloop environment, that control center still had one dependency on a cloud service, Route 53 from AWS, you might know it. We needed to get rid of that because without getting rid of that, we couldn't make a fully air-gapped Mojaloop deployment. You will have heard some of the folks from RSwitch and Widen earlier talking about how they had to create private Docker registries and the such like private code repositories because they have a deployment that needs to be air-gapped. They have PCI DSS and regulatory requirements that mean they can't have any external internet connections from some parts of their system. So we wanted to eliminate that final dependency. And I can announce that we have now successfully done that, thanks to the work from Infotex on the IIC. So the old Route 53 dependency has been replaced by something called Core DNS. Those of you familiar with the Kubernetes space might know this one. It's quite a popular plugin. It has a plugin architecture itself, which lets you choose a particular DNS backend based on what you might have in-house already or your preferences. So you can even use Bind. Some of you might know Bind, the old Unix and Linux DNS server. Through too many to mention DNS server products that are out there in the market, both proprietary and open source. So Core DNS allows you to build or use off-the-shelf open source license-free plugins to plug in your own DNS here. And the DNS is important because it helps name resolution, both internally within the Kubernetes clusters and between those clusters and the outside world. So participants may be on your private network. So as well as that, continually in the background, our core IAC has been improving. Again, as pushed forward by the COMESA project, significant work has been done on simplifying and refactoring much of the IAC to improve its resilience. So the control center now has carrier grade redundancy capability, 2n+1 instances of everything that can be deployed across multiple independent failure zones. So not only are your switches able to be deployed fully redundant, now the control center itself can be deployed fully redundant as well. As part of this, the IAC documentation is being improved with user feedback. That's a continual process. We are aware that the documentation needs beefing up in that area. Some people say Mojaloop has too much documentation. It probably does when you look at the whole thing. Mojaloop has lots of components, but each one needs documenting in detail. And the reason we do that is so people don't have to rely on finding someone who knows to be able to ask a question to get something done in their space. So we're putting considerable effort in the coming PI into improving the documentation on IAC. Also, over the past PI, there have been multiple recent on-premises deployments that have been successfully performed by members of our community, Infotechs on COMESA, and also our friends PACES. So at this point, I'm going to hand over to Azim, who's kindly volunteered to talk just a short bit about their experiences with deploying on-premise. So I think we have to switch to a different slide deck now.
Yeah.
Here we go. So over to you, Karim.
So just to give a quick overview of what we did. Yeah. So there are two types of hardware being used over here. I'll explain the reason why when we move to our next slide. So in our first attempt, we actually tried to do the installation on the DL380G9. DL380G9 is a HP hardware. And then in the second attempt, we tried to do it on the IBM Flex system, which was a little older version of hardware, but we had what we had. So we wanted to do an on-premises deployment. This was the alternative that we had. The hardware used both side, two types of processors, Intel Xeon CPU E5 2683. On the IBM Flex, we have Intel CPU E5 2680. On the DL380, it was a little advanced version 2683. Software stack, we had hypervisor VMware ESXi 7.2. On operating system side, we didn't use any operating system as a container operating system. We used the full RHEL 8. And for the orchestration of Kubernetes, we used K3s. From the results perspective, I wanted to be very quick. Why it didn't work on the DL380, there is a dependency of MongoDB to have some AVX2. AVX2 is something like advanced vector, as advanced vector accelerator extensions. Yeah, thank you, Miller. So advanced vector accelerators is something that is a requirement of NoSQL, and it is essentially not supported in some of the CPUs that we had in DL380 Gen 9. So we had an you can say a little older version of a CPU in which it was supported. We installed it out. It worked flawlessly. It is working flawlessly. The demo that I showed to you guys was using that infrastructure. And there are certain things that I wanted to like bounce back with James as well. So James was talking about core DNS being one of the dependencies, but I do find it very concerning that we need to have something around an NTP. So NTP is an issue because when you are actually deploying in a hypervisor environment, there are different hosts, right? And so if you have a cluster of different hosts in our data centers, like the DL380 was residing in a different data center, the IBM Flex system was residing in a different data center. And since we have a cluster of ESXi managing all the VMs moving across any number of nodes, it actually became an issue. So what happened was that one VM was so one worker node was residing on one host, the other worker node was residing on another node, and there was a, you can say, 4-5 second delay between both of these host machines, and you don't have an NTP working, and all of a sudden you start getting these kind of messages that you're doing the transaction in future. You can't do a future dated transaction because one of the servers actually generated a date of future, right? This is something that we have to actually cater for in the entire Mojaloop ecosystem, alongside these kinds of issues like the CPU and AVX2, which is essentially not a dependency of Mojaloop, it's a NoSQL thing. But we need to know, because once you are doing an on-premises deployment, you need to make sure all the RFPs that you create must have these things, right?
Yes, absolutely. Yeah, we've been aware of the clock drift issue since day one. Since day one on Mojaloop. And I believe we do have some written recommendations somewhere that talk about NTP and how you should configure NTP in your on-premise deployment. I think you used the Helm charts to deploy
Yeah.
rather than IAC. Yeah, I've got a feeling, and I'm not 100% sure. Maybe if David Fry from Infotex is online, he can confirm this, or one of the Infotex guys who know the IAC can confirm. I think NTP gets deployed as part of the IAC deployment. If you use the Helm charts by themselves to deploy, there are some aspects that you will be on your own with that you have to manage yourself. I'll look into that. And if we don't have NTP in IAC, I'll make sure that we do have soon.
So the thing is, like, we
Thank
were
you.
using K3S. So probably that, because K3S is a Kubernetes certified installation provided by Rancher.
Yes.
So that is something like probably they don't have it as a part of, like, they're offering as a Kubernetes orchestration.
Yeah, K3s is certainly supposed to be a cut down version of the bigger full-on Kubernetes deployment. So it's possible that K3s doesn't come with NTP and the bigger one does. I think it's a really great point, and thank you for bringing that up. Certainly the very early deployments that were done in cloud, we even noticed clock drift across VMs in cloud, and that became a problem in some of the early deployments.
So in cloud, like, so if you have a deployment, so for example, you have a deployment in a different availability zone, you still have the flexibility of the cloud doing all the synchronization of times and all these things. But
yeah,
the thing is, when you work in a on-prem deployment, you have like people actually working on the all of the infrastructure. They'll have certain boundaries. So in our case, we have like multiple data centers, and there are two separate data center administrators who have a separate set of people who do infosec for two different types of data centers, and then there are silos around them.
Do those two data centers have different time sources, or do they both synchronize to the same?
So the thing is, we had the both have different firewalls. So
okay.
So all of the NTP, or you can say time synchronization on the host, were with the firewall, so they can actually get skewed 2-3 seconds
through the firewall.
Yeah.
Okay, that's really interesting. Thank you.
I guess that's about it.
Yeah, thank you. Well, congratulations. I know lots of people work very hard to make that happen. Thank you.
Thank you.
Thank you very much.
You guys for all the support. Thank you.
You're very welcome. Sam takes a lot of the credit there, I think. So can we maybe move back to the slide deck? sorry, to the first slide deck. Sorry, I'm really complicating things by moving around between multiple decks today. I apologize. Thank you. It does come with IAC. Just heard from outside the room. Fantastic. Thank you. Where was I? Yes. So thank you, everybody. There's so much work happened behind the scenes, particularly in IAC. The maintenance of the Helm charts, Sam and his team do an awful lot of maintenance there on the Helm charts. People in the community who give us feedback all the time. So much effort and contribution has gone into this, to making this work stream possible, and contributed directly to the success of the on-premise deployments that are out there in the world right now. So thank you very much, everybody. You should give yourselves a round of applause, I think.